So we are continuing the same paper. You can see it is 062042 from October, November, and 2021. And this is question 5 of the same paper. So here it says iron is a transition element, potassium is a group 1 element. Iron and potassium have the same type of bonding. Name and describe the type of bonding. We know that potassium is a metal, iron is a metal, so we can say it is metallic bond. So the bond is what? Metallic bond. Even just you can write just metallic. Description, you have to write the definition of metallic bond. What was? Lattice, or starting with electrostatic electrostatic force of attraction between lattice of positive charge ions, positive charge metal ions or just ions, and C of delocalized free electrons. Okay, so this is the description, mean this is the definition of metallic bonding. Next, B part, transition element and group 1 element have same or have some similar physical properties. They can both be hammered into a shape, conduct electricity, be stretched into wire. So remember, this is malleability, this one is electrical conductivity due to the presence of free electrons, and this is again malleability, but it's called as ductileness. Okay. Now, the demand is name the term used to describe the ability of elements to be hammered into a shape. What I said is malleable or malleability. Describe what happened to the particles in iron when it is hammered into shape. We can say slide over each other. Slide over each other. Even you can write just slide, but writing the complete sentence make a sense. Next, suggest why copper rather than other transition element is used for wires which conduct electricity. So here we can say due to its unreactivity, due to its unreactive nature. But remember, it is not unreactive like a noble gas. But as compared to other transition elements, it is comparatively unreactive. Understood? So here he says that transition elements are harder and stronger than group 1. Describe how two other physical. Remember two other. Now you are not going to describe strong or strength. You have to mention that this is the physical property. So we can say group 1 metals have low melting than transition. Okay, and then the next you can say group 1 metals have low density than transition metals. Understood? So you have to write in a comparative way. Okay. Okay, we have to finish this. Complete the question. Here he says chemical properties of some group 1 elements are shown in the table, and we have to complete. Here we can see the flame test. We learned that the sodium, flame color of the sodium is always yellow. The flame color of potassium is lilac or lilac. And then, as you can see, the reactivity is increasing. Okay, so what we can say here, it is steadily, then sodium strongly, potassium very strongly. So we can say even very strongly or vigorously. Okay, and then this will be the common form color solution. Forms a colorless solution. And here quickly, so you can just write very quickly forms, because we know that as we go down the group, the reactivity of the metal increasing. Okay, quickly forms an oxide, so we can say very quickly forms an oxide layer, an oxide layer. As this color was in not in our flavors, so it is already provided. So you may have to keep that color in your mind. Maybe in next paper it will help. Okay. Add to the table. So already we done this. Name the gas produced when group 1 elements react with water. So it is what? Hydrogen. It is hydrogen. Name the solution form when potassium reacts. So we can say potassium hydroxide. Potassium hydroxide. Next, predict the pH. As it is the formula of the potassium hydroxide, we can say it is KOH, contain hydroxide ion, and group 1 alkalis are stronger, so we can write any value higher than 8, but more perfectly you can write 13. But you can write any value higher than 8 till 14, any value. Then write the chemical equation for the reaction of sodium with oxygen. So sodium is represented by Na, and it is solid at room temperature, reacting with oxygen, which is diatomic and a gas. So when they react, they produce sodium oxide. So the formula is Na2O. As it is an ionic compound, so it will be solid at room temperature as well. So to balance this, we have to multiply here 4, 2, so it's balanced. Okay, understood? Quickly moving to finish the question. It says iron is a typical transition element. It is the catalyst used in Haber process. Write the equation for the reaction that occur in Haber process. So I think you remember that. What was that? We are going to react the hydrogen with nitrogen. Hydrogen obtained from cracking of the oil or natural gas, nitrogen obtained by fractional distillation of liquid air. When they react, they produce ammonia, NH3. And the equation is also reversible, so you have to write, okay? So to balance this out, we have to take 2 here and 3 here. Equation is balanced. Then he says state the temperature and pressure used in the Haber process. So temperature used was 450 till 550. But remember, we are not going to write in the range, we have to write only one value. So in this way, I'm going to write the mean value, which is 500 degrees Celsius. Pressure, we learned that the pressure is used 300, 200 till 300. So you may write any value or in between the value. So you may write 200 or 250. So I'm going to write 200. Sorry, pressure. So we have to write ATM, atmospheric pressure. So the question is finished here. So we will continue with the next question, inshallah.